All right, hello everyone. So today we have a discrete math problem. Use the Euclidean algorithm to solve for x. 19x is congruent to 1 mod 101. The equation ax is congruent to 1 mod n has a solution if and only if the GCD of a and n is equal to 1. So we're going to use that fact here. In our case, 19, the GCD between 19 and 101 is equal to 1. Okay, so that'll work out because both 19 and 101 are actually prime. So for sure the only thing that divides both of them at the same time is 1. Okay, so what we're going to be doing essentially is applying the Euclidean algorithm on 19 and 101. And let's go ahead and do that. So we're going to say 101 equals 19 times 5. 19 times 5 is 95, plus you have a remainder of 6. And next I'm going to take 19, and 19 equals 6 times 3 plus 1. And then finally here, actually I really don't need this part, but 6 equals 6 times 1 plus 0. And yeah, we're done. Technically, with the Euclidean algorithm, if you apply to the GCD is the last number right here before the remainder is 0. And what I'm really going to be applying is these two lines over these two equations. Okay, so first of all, notice that I'm going to take the second line. 19 minus 6 times 3 is equal to 1. Okay, so just rewriting the second line, 19 equals 6 times 3 plus 1. That's equal to saying 19 minus 6 times 3 equals 1. And if you take the first line, or the first equation, I'm sorry, I'm not reading a book, and you have 101 equals 19 times 5 plus 6. And what I'm going to do with that is as follows. I'm going to take 101 and subtract 19 times 5, and that's equal to 6. And what I'm going to do is I'm going to replace the 6 in the first equation with 101 minus 19 times 5. Let's go ahead and do that. So 19 minus 101 minus 19 times 5 times 3 equals 1. And I'm going to distribute the 3. And this is the result that you get. Now I'm keeping the numbers as such. Let me explain that right now, because I'm gonna find what that x that I'm looking for here is. So you have 119 plus 15 19s is 60 19s minus 3 101s, so that's all equal to 1. And that value of x that we're looking for is actually 16. Now why is that? Because if you look at that equation, ax, or the congruence, congruent to 1 mod n, this is true of ax minus 1 equals n times some integer r, or in other words, ax minus n times r is equal to 1. So that's essentially what we have when we say 16 times 19 minus 3 times 101 equals 1. So the x that you're looking for has to be 19. Okay. Oh, I'm sorry, not 19, 16, excuse me. I'm sorry, 16. Wrong circle there. So it's 16. Okay. So that's why that's the case. So when you're applying the Euclidean algorithm, you apply it like you usually what you find for a GCD. And when you usually will just need all the lines, well, not usually, you just need all the lines up to, except for the last one where you get 1 here. Yeah, everything from here above you're going to work with. And what you do is you take your 1 and you rewrite it in terms of the two numbers that form that combination, basically. So 19 minus 6 times 3 equals 1. And then what you do is you go to the line above that and you replace the value, in this case of this remainder 6, and you take that and you rewrite that as 101 minus 19 times 5, and then you plug that in for your 6, and you might need to do this again if there's like another line here, okay? And what you want to do is you want to combine and write a combination of things in terms of a and n, okay? So you want to have something with 19 and that 101, which we did, and whatever that number is next to the a at the end, that is your answer, so it's 16, okay? So that's how you find that answer to this equation, and it's very useful for solving some general congruence equations, which I will link to this video as well. Okay, thank you for your time.